Hello my friends. Here to talk to you about drawing random numbers. I showed you this slide here at the lectures, and to some that was perhaps a bit too rapid to really grasp what's going on. But I want to explain how we draw random numbers and why it works the way it does. The way that it works is that any computer only knows how to draw uniform random numbers, and then it uses the inverse of some CDF on those uniforms to get the draws from that particular CDF. So let's slow this down a little bit and have a look at what's going on. So when we draw uniform numbers, it could be something like this. The rand function will draw uniform random numbers. And what it means is essentially that if we drew a whole bunch of these and did a histogram, let's take 10,000 draws and do a histogram of U, then this is what we get out. It's approximately flat, so you can see that we have something just over 500 observations, or between 0 and 0.5 or 0.05, just under 500 here, close to 500 here. And if we keep increasing the number of draws, make it very large, and draw the histogram again, you can see that it gets very, very, very flat. And this is basically here, it's just reducing the width of the histogram bins. So as you can see, it gets very, very, very close to completely flat. That's what uniform numbers means. It means that 10% of the observations will be between 0 and 0.1. 10% of the observations will be between 0.1 and 0.2, and so forth. That's what the uniform distribution is. It's numbers that are between 0 and 1, and there's the width of the interval gives you the fraction of the observations that are going to fall in that interval. That's what the uniform distribution means. Now what we want to look at is, suppose we draw random normals, which rand n does for us. Then we've looked at these distributions a lot, and this is what they look like, the good old bell-shaped curve, but how does it actually come about? How does it do it? The computer doesn't, what this tells us is that about 100 observations were between just here around -2, whereas close to 0 we have about 800 observations. How does the computer know where to put them? Well, it actually doesn't. What it does is it draws uniform numbers, and then it takes them through a mapping. What does that mapping look like? To show you a mapping, I have to first get some x values. So let's take some x values between 0 and 1, and let's take 1,000 values. Now xx, here you can see it's just counts up from 0 and then moves slowly up 0.991, 0.992, 0.993, and so on until it gets to 1. And then let's take a look at, let's create some y values which we want to be the inverse normal. We can also use this function instead, ICDF, inverse CDF of the normal distribution, evaluated at xx, and we want 0 mean and 1 and unit variance. Now we can plot xx and yy, and this is what they look like. This is the inverse normal CDF here. So you can see that it maps interval from 0 to 1 over to, it goes down to -3 and up to +3 here. And it's the inverse of, suppose we create the, let's create a plot where we take xx to be linspace of -4 to 4 and 1,000 points, and then y, we set that equal to the CDF normal of xx, we want 0 mean and unit variance, plot xx and yy against each other. This is the cumulative distribution function of the normal. So in a sense, I'm just flipping this one around when I'm doing it the other way, and I'm using the y-axis as the x-axis instead, and this x-axis as the y-axis. So let's get it up again. Here we go. So this is the inverse. Now, How it works is whenever we draw a uniform, remember that there's a 10% chance to be between 0 and 0.1, 10% chance to be between 0.7 and 0.8. That's what the uniform distribution means. So we draw a number here, say it's 0.6. Then we go up here and look here. Then we're close to 0. It's 0.3, say. Then we draw another uniform. Maybe it's 0.2. We read here, and that goes over to -1. And as we keep mapping these points over this way, we can see that we're going to get a lot of points in here. A lot of these numbers are going to map over here close towards 0, maybe between -2 and 2. And very rarely, only when we get very close to 1 or very close to 0, do we get outside of -2 to +2. So we have to get like 0.999 to get over to 3. So let's again draw some uniform numbers. Let's take 10,000 uniforms and look at them again. This is what they look like. Good. So now let's create X as take this inverse CDF of the normal distribution, evaluate it at all the U's, 0 mean and 1 unit variance, and let's look at the histogram of X, and here we go. Gets a beautiful normal distribution. And similarly, we could have created a different variable. Let's call it Z, taking the same U's, but let's use the generalized extreme value distribution. And let's look at the histogram of the Z's. That looks like this. So it's a different distribution from the normal distribution, you can clearly see. This is the one that is used to generate the random utility models. So as you can see, all we're doing is taking these U's, working them through these functions, and again to remind us what the functions look like. It's these functions that map 0 to 1 over on the real line. And when we draw a bunch of uniforms down here on the x-axis and fire them through this inverse mapping, then the histogram that comes out on the other side will be the histogram of the CDF that we've used the inverse of here. So that's how we draw random numbers